Today we are talking about AWS VPC, the virtual private cloud service that is offered by Amazon. And some of these functionalities are the foundation layer of your AWS cloud. And we will see what is in VPC, what are the different components that make up an VPC, and we will cover some basic use cases like creating a custom VPC with internet access, without internet access, and also how to connect your multiple VPCs in the same region. And also we will see if you want to connect it to your on-premise networks, what you need to do. And in the hands-on demo, I'll show you how to set up your custom VPC with NAT gateway so that you can have a highly secure production grade VPC configuration. So when you're talking about VPC, this is a part of the networking group of service, and there are many of them, but this is almost always the foundation service or the first thing that you do when you are going to AWS cloud, because VPC provides all the different components that are required to set up your resources, starting from the IP address that you need to connect to that resource, and the routing tables that can send traffic inside your VPC or outside your VPC, and also the internet gateways and the stateless firewalls and stateful firewalls, and all those different components. So if you are saying that you are going to launch something in AWS, almost always the first thing that you are going to do is set up an VPC. And for setting up an VPC, you need a few things. Before that, let us see what exactly VPC means in AWS words. What Amazon says is it's a logically isolated area which provides a common security and interconnections. In my opinion, what it means is there are a lot of resources are going to be there in your cloud. It's going to be some of them web internet facing. So people call that a web tier. If you take it as a three-tier architecture, some of them are the middleware layer or app layer, and some of the resources are going to be at the database layer at the back end. And each of the security configurations for each of these different tiers will be different. The web layer will have additional intrusion detection systems, firewalls, whereas your application tier will accept connections only from your web tier, not from your internet. Whereas your database will be very highly secure, where only certain application servers can connect and not all application servers also, and only certain people can connect. So you will have certain security standards for certain tiers, and even within the same tier in database layer, for example, all connections will not be accepted, only a particular incoming IP address will be connected. So the VPC provides all these aspects of it which are useful in a real world. So if you're going to set up a custom VPC that is for your customers, you will need these four high-level components. That is, first thing is choosing an IP address range, which is going to define how many resources that you can launch in this VPC. Say your customer says, I have 2000 VMs, then you need to think of 2000 VMs for service level IP address, and then administrative IP address. And then if you are going to launch some IoT devices, or if you are going to set up some management services like jump server or backup server or monitoring server, then you will have some X amount of additional IP addresses required. So you come up with an IP address range saying I will need 2500 instead of just 2000. So the next thing is setting up your subnets in your availability zones. So if you're going to launch them in a region like Virginia where there are 6 availability zones, then you need to be carefully splitting your IP address range between all those different ACs, because if you're going to use autoscaling, and autoscaling is going to launch our instances in different ACs, and for that autoscaling will need subnets in those ACs also. So we need to spread our VPC across all the availability zones that is inside that region, so that you can have a high availability configuration from VPC level. Next is creating an internet route, that is setting up your route tables in VPC. We will see that how to send internet traffic to a certain place and how to route internal traffic to a certain place. And finally, you are going to write your security group rules to say that for web tier, open port 80, for database tier, open port RDS port is 3306 for MySQL, and for Oracle, you will do something like 1521. So the port will be dependent upon what application that you use. You don't have to really know that, but you can set up stateful and stateless firewalls. We will see all of these components in a short while. So let us go and see the first thing, choosing an IP address range. In VPCs, the IP address range is called as the CIDR choice, or classless interdomain routing. I would strongly recommend you to go and get yourself familiar with what exactly this notation means. In short, choose your CIDR block in consideration with number of IP addresses you need today and also to accommodate future growth. So the maximum and minimum is shown here on your screen. And also you need to ensure that you are going to spread your VPC across all the availability zones by creating multiple subnets. So in one subnet only you are planning to use, or in one availability zone only you are planning to launch your resources, but you need to plan for your future and spread your CIDR range across the ACs. So choose a range which will allow you for that kind of growth in the future. So now that we have set up our CIDR range, let us say /16 is the one that we have taken for this scenario. And the first thing that I'm going to create is my public subnet, and I'm going to subdivide my CIDR by saying I want my public subnet to have only 256 IP addresses, and this IP address range is going to be /24. And next thing that I'm going to do is, now public is done in one availability zone, I also want a private subnet. So let us go ahead and create one more private subnet, and I'm going to see here the in one ACs I'm using this contiguous series. So it is 1.0/24, that is the starting IP address is 1.0 and the last IP address will be 1.255. And remember, Amazon consumes 4 IP addresses, so you will be ending up with actually 1.251. And the reason that Amazon uses those 4 IP addresses is for internal routing, research purpose, and modifications and all those things. But remember, 4 IP addresses are always reserved for Amazon's personal use in each subnet. So we have done public and we have done private also, but we have done it only in one availability zone. If I have to take it to other availability zone, I will go ahead and create something like this. And here you can see here the range has increased to 3 here, and then the range has increased all the way to 4 here. So this way I can create an highly available configuration from the VPC level itself, that is a multi-AC, multi-subnet configurations. And sometimes people go ahead and create one more subnet, which is a reserve of the remaining IP addresses, so that you can go ahead and configure them in future also. So you know clearly how many IP addresses are still left, and that will allow me for a growth. So people call it as a spare subnet, and I personally recommend creating a spare subnet so that you know how much is left out. So now that I have set up my VPC, next thing is I need access to my public subnets to give access to public subnets to the internet. So in Amazon, the only way to do that is you need to go ahead and create an internet gateway and attach it to your VPC. So the internet gateway sits at the boundary of your VPC as shown here, and then once you attach it, you can send traffic to this internet gateway, and all the traffic from your web subnets can flow here now. So how do I do that? I'm going to create some routing tables, and that routing table is going to allow me to send the traffic. So when you are talking about routing table, Amazon will have an internal VPC router. You don't have to do anything, but each VPC comes with its own internal router. So automatically all the traffic from public and private will go there. But when you have a specific route, something like this, the destination for internet traffic is always 0.0.0. And if you say that all traffic destined for this IP address, send it to internet gateway, then the VPC router will automatically send my public intended traffic through this route table and send it across to my internet gateway. So that is how the VPC router helps in by applying certain rules and filters. Say any traffic that is coming from private, it will bounce back here itself, because it won't allow it to the internet, because we won't have a route table for that. And route table will use this notation saying this is a private subnet CIDR, and any traffic originating from here, do not send it to internet. So that is how the router will understand where the traffic is coming from and whether it should send it to public or not. So now that we have done our routing tables, now we are going to look at securing our public subnets. So how do I do that? Amazon provides a service called as a security group, and it acts as a virtual firewall, and it is also called as a stateful firewall, because what it means is you don't have to configure separate rules for inbound or outbound. Just you configure your inbound rule saying any traffic for destined for port 80 in my public subnet, allow it. So from the internet, let us say I am saying port 80 is allowed, and it is coming from a specific IP address saying 1.2.3.4, and return traffic will also send back to the same IP address. That is what a stateful firewall means. I am going to configure only one rule, that is the inbound rule. And I can go ahead and configure more than one rule for my instances. In public, I will configure one rule for port 80 and another rule for port 22 to do some administration. Or if my application is running on say port 8080, I can configure another rule also. So when I say web security group or security group, you can have n number of rules, and each of those rules will be applied to all the resources sitting inside that, and this is spreading across your VPCs. So you can associate one security group or multiple security groups also, depending upon the granularity of the control you need. So this is on the stateful firewall side. Amazon also offers something called as stateless firewalls. We will see that in a short while. But this is, I'm showing another example of a security group at a database tier now. Here I'm saying from for the private subnets where my database is going to reside here, I'm creating another security group called as a database security group, and I'm going to create an explicit rule saying accept traffic only from my web security group. Do not accept traffic from anywhere else. So when I set up a rule like this, automatically my database is not going to accept connections from the internet, and it's not going to accept connections from any other VPC. It is not going to get connections from any other IP address unless those IP addresses are from this range, and also from this range my security group at DB level will reject all the traffic. So you can also write an explicit deny rule also, that is also possible. Now I just gave you an example of allow rule, which says allow everything from web security group, and I can also write an explicit saying anything other than web security group, deny it. That is also possible. So you have a configuration of both allow and deny in security groups, and you can take your application logical structure also when creating the security groups. Here I've shown as an example of web and DB, and in case your company has a different application structure, like a middleware tier is there, you can go ahead and write an app security group or archival data security group or log security group. So you can follow any structure you want. It's fully flexible and customizable for you. So this is how a security group visualization looks like. I'm having a one security group here from the traversing it from the top. Let us say I have a security group which allows port 80 and 443, and I'm allowing it for the internet access. So anybody coming in from the internet will be allowed to access my web tier only, not my bastion host or any other application. So the traffic goes and lands only in my web tier. But I want my administrators who are going to come from a corporate IP address, a particular IP address, or a particular series of IP address from my enterprise. Then I'm going to say that all those traffic will be routed to my bastion host that is sitting here and only on these two ports. If they are coming from any other ports, it will be rejected, and if they are coming from any other IP address, that will be rejected. And all this traffic will be destined or landed on this bastion host only. They will not be reach my web tier, they will not reach my app tier or database tier. So this way, admins cannot go ahead and log in directly to any of my production servers. So if I want to move some data from on-premise to cloud, and if I have a synchronization or asynchronous pull, then I will configure and sync with my database, and I will say that if this particular IP address is coming and it wants to connect to my this database tier, then I will go ahead and set up an VPN, and I will allow that traffic also. So this kind of a configuration is also possible. Any other traffic which is not meeting any of these rules are by default blocked. So in other words, VPC is secure by default. You have to open it for internet access or your on-premise access. And any other traffic which is not configured for internal communications will be rejected by default. That's what this image shows here at the bottom. So how do I do that? This is some of the snapshots to help us understand how we are going to do our security groups in the AWS console. We will see this in demo also, but it makes it easier to understand how exactly it looks like in the console. So for example, here is a web security group configuration, and I'm saying that for web security group, I need port 80 to be open, and the source traffic has to come from 0.0.0, that is from the internet. I'm allowing access to port 80, and any instances that are applied with the security group will receive traffic from this IP address. So that is how a web security group will look like. And you remember the source part. Let us go to a database security group and see how it looks like. I would like you to make a note of this one also, the security group ID, which says SG82 blah blah blah. If I go to database now, I am in my custom database security group, and you can see here the port range is going to be your application. Here's dummy number 2345, but the source is my web security group, and it's the same as this one, if you can notice. So this way I'm going to absolutely ensure that only my applications are talking to my database and not from the internet directly, or nobody can try and hack into my database. So that is how security is set up here. And the final thing is the stateless firewalls service offered by Amazon. It is called as a network access control list, or it is, in other words, it is called as stateless. The reason for that is if you are defining something as an allow rule, you will have to go ahead and define the outbound rule also explicitly. It doesn't remember where the source IP address is coming from, where the request is coming from, unless you put in the outbound rule saying send it to this location. It will block all the traffic. So you need to write both inbound rules as well as outbound rules in NACLs. And remember, all the rules are executed in a numerical order. Say the smallest rule will be rule number will be executed first. In this case, 100 is there. Let us say the next rule is 150. It is going to keep on increasing and executing in this order. So if you are going to deny first, and then later if you're going to go ahead and write another rule, say allow, that allow rule will not work, because the smallest rule number always takes precedence. And the star that you see there at the bottom is for any traffic that is not matching any of the rules that you have written above that, then that traffic will be by default denied. So this is another way of ensuring security of your VPCs. And quite often, most of the security considerations are done at security group level itself. But if you want to be very, very explicit and absolutely certain that only this traffic is reaching my servers, then you can go ahead and configure your network ACLs. But most use cases, or common use cases, or simple use cases, network ACLs by default, whatever configuration they are there, should be enough for us. And network ACLs apply at a subnet level, whereas your security groups apply at a VPC level. So there is another distinction between security groups and network ACLs. In short, there are three things I would say. One is stateful, that is security group. NACLs are stateless, and here you need to write the explicit inbound and outbound because it is stateless. And in NACLs, they are at a subnet range, and whereas security groups are at a VPC range. So let us move forward here, and this is what this animation is showing us. It is on a subnet level basis, and there is a explicit rule for saying internet traffic is allowed here. This is the routing table. So we have set up our VPCs, we have set up our subnets, we have set up our internet gateways, and we are going to set up our routing table explicitly now. By default, every VPC comes with one default route, and you will not be able to modify that. What this means is any resource that is inside that VPC, let us say there are two servers inside your VPC, and both of them can talk to each other without you going ahead and doing anything on the routing table. That is because Amazon has a default route table put in place, and that ensures that all the resources inside that VPC can talk to each other without any additional configuration. But having said that, you can go ahead and configure your own route tables on that and apply them to different subnets. Like NACLs, you can associate a route table to particular subnets only. So in this case, let us say public subnets are there and I want to give them internet access. Then you can go ahead and associate your internet gateway and then say the destination traffic is 000 and pass it on to my internet gateway. So that is also possible. So you have one default route table and you can go ahead and customize your route table to add internet traffic. In this case, quite often internet gateways are referred to as IGWs in VPCs. And then in this VPC, an internet gateway is created and attached to my VPC. And this is how the route table will look like. All the traffic, this is destined for 000, will be sent to this IGW, and from here it will go to the internet and it will receive traffic, also send it back to my VPC. So that is what an internet gateway does for you. And it is a 1:1 mapping. One VPC cannot have two internet gateways. Absolutely not possible. So it's just 1:1. The other service that Amazon offers as part of the VPC is DNS. If you remember, when we are starting an EC2 instance, it gives a nice big name saying EC2-IP address Amazon AWS.com. You can connect your server with that public host name also, and you can browse any websites that are configured on that server using that host name. But that service is provided because there is an option called as DNS resolution and DNS host names. Both are given here at the bottom. When you create a VPC, on the bottom right hand side, you will see that. So when you choose the option as yes for these two services, then Amazon provides you automatically the host names, and it will also provide the necessary routing to reach those host names using a DNS service inside that VPC. So you have these options also. If you don't choose this, you don't get that big host name, and you don't get the routing using that host name also. You have to use only your private IP address to communicate with your instances. What does mean that is, you can have your own domain name inside your VPC. You can have your custom domain name, and because this routing is not going outside to the world, you can have your own www.google.com or www.myname.com inside your VPC and have all the instances communicating using that domain name that is provided by the VPC itself. Of course, if you go ahead and set it up for public access, you will be causing a lot of trouble for outside people, and you will be questioned for setting up a domain name, and that traffic will more or less will be blocked and it will not happen. So there is something called a private hosted zone in Route 53. I will show you how to set up this when we are doing the Route 53 sessions. For now, let us remember that VPC allows us to create domain names, and using Route 53, we can create our own private hosted zone inside our VPC. So this is a broad overview, a summary of all the security features offered by your VPC in your AWS cloud. So if you want to lock down your instances, then you go ahead and configure your security groups because it applies at instance level. Then you can have multiple security groups also, not just one. You can associate one instance with multiple security groups. Then if you want to isolate your network functions, say private, public, data layer, archival layer, or management monitoring, then you can create multiple subnets for each of them. And once again, one availability zone can have multiple subnets, and your subnets can be bifurcated to the number, any number you want. You can have /24 and /28 also. Remember that when you want to isolate it. And if you want to lock down your security at a network level, because if you remember, subnets are associated with your NACLs, and you can go ahead and configure NACLs for inbound or outbound. So you have additional security at the network layer, and even at the network layer, you can aggregate your functions by routing it. To say whether you want to send your database traffic directly to the web traffic, or you have to go it only through the application. Then you can have more restrictive routing also to ensure your security. So these are the top level functions. One is security group, another one is subnets, another one is NACLs and routing tables. Combined together, they make your VPC really secure.